Hello everyone, and welcome to the third part of building a simple Dropbox clone. Last video, we finished building most of the UI component. In this one, we'll use Deno KV as our persistent layer to store the files and folder information. Deno KV is still experimental and doesn't have a stable release. So to use it, we need to add the unstable flag when running our Deno application. To do so, head over to your application and the deno.json file and update the start task right before dev.cs by adding the unstable flag to it. To also add the IDE support when using features that are part of Deno Unstable, we need to include the reference to it in the main TypeScript file. So if we go to our TypeScript file, right under deno.ns, we can add a similar reference to deno.unstable. That's all the setup we need to start using Deno KV as our database. Before writing the functions to store files and folders, we first need to define some interfaces to represent our folders and files. Let's create a folder in the root directory called modal and a file called file.ts. We'll export an interface that will represent a file in our application. We'll call it fresh file. It'll have an ID of type string, a name of type string, and a parent folder of type string. The parent folder represents where the file lives. So when we later create a folder called books, for example, and inside of it create a file, that file would have as parent folder books, the ID of books. Next, we'll create a new file in our modals folder called folder.ts. We'll first import our fresh file interface. Then we'll export a folder interface. This will have the same structure as our files interface, so we'll have an ID, a name, and a parent folder. We'll create also another interface called subcontent. This will be used to represent content for a folder. So based on the previous example, if we're in the books folder, we know that the books folder can contain multiple files or other folders. This interface will hold that information. So this will have a list of subfolders as well as a list of subfiles. Finally, we'll also export another interface called page folder. This will have the current folder that we're looking at, and it'll have our subcontent. That's all the interfaces. Let's create the functions to save and get files and folders. We'll first create a new file under our utils folder called db.ts. This will store all the logic for our database actions. We first import the fresh file and folder interfaces. We then want to create our KV instance. This is done by calling deno.openKV. When no path is provided, the database will be opened in a default path for the current app. Let's first start working on how we can save a folder. We'll export a function called saveFolder, which takes in a folder and returns a promise of void. There's a simple way if we wanted to store things in Deno KV, but we have to keep in mind that we also want to fetch all folders based on the parent folder. For this, we can make use of secondary indexes. This will allow us to query multiple folders based on a shared attribute, the parent ID. So how do we do this? First, we create a constant to represent our primary key. Deno KV is a key value store, and keys, or as they're called, key spaces, are represented as lists, which allows you to have multiple levels. In our case, everything folder related will be inside of a folders key, which will contain a bunch of IDs. We then create the by parent key. This is our secondary index, which lets us query by the parent folder. We give it the index name, in this case, the folders by parent folder, the attribute that we're interested in, so the parent folder attribute of the folder interface, and then we pass it the ID that it maps to. We'll then create an atomic transaction. So as long as we don't call commit on this, nothing we do will actually be updated in the database. We'll first want to add a check that checks if the primary key is unique. If this fails, it won't execute anything. Then we set the value for both our indexes. So first for the primary key, passing it the object that we want to store, and then our secondary index, passing it the object that we want to store. And lastly, we commit everything. And that's how we add an item to our database that requires a secondary index. Next, we need a way to get a folder based on its ID. So we'll create another async function called getFolder, which takes in an ID of string and returns a promise of either a folder or null, since it's possible that this ID doesn't exist in our key value store. To get from our database, we call the get function on our Deno instance, and we specify the type of the object we're getting, which in our case is a folder, and then we pass it the key space, which is folders and the ID that we're looking for. We can then return the value, which will be either a folder or null. We also want a function to get all the folders based on the parent folder. And since we created our secondary index during the save step, it's very easy to do so. We'll create a function called getFolders, which takes in the parent ID as type string and returns a promise of a list of folders. We can use the list function in our KV instance and tell it what type we're expecting. And then we pass it an object telling it what we want. So the prefix of it would be the secondary index and the parent ID, which maps to our by parent key. So we're looking at everything that matches this. So we're trying to get all the folder IDs that match this specific key space, folder by parent folder and the parent folder ID. This will return an iterator. So we create a variable called folders, which is initialized as an empty list. We loop over the iterator and then we add every value to it, and then we can simply return that. Okay, we're almost done. We also need to have the same three functions for our files. So let's create a save file function. It behaves exactly like the save folder one, except it takes in a fresh file. It's looking at files as the key space instead of folders. And similar here for the secondary index, it's files by parent folder. And then we also use the file object, which we store. The get file function is the same as the get folder function. We're just specifying the type as a fresh file, and we're looking into the files key space. And similar for get files by parent ID, we're using the secondary index that we specified during the save files function. And yeah, we get an iterator, which we then map over it and push everything into a files list. We now have our database functions ready, so let's make use of them. To make use of it, we'll head over to our index route. We'll need to add some handlers, a get handler and a post handler. So first, we'll also import the handlers and page props from Fresh, as well as the interfaces, the folder and subcontent interface, and we'll import some of our database functions that we created related to folders and the files. Then we'll export our handler, which will be of type subcontent. The get handler will basically get all the folders and files in our database for the current folder we're looking at. Since this is the index route, which is a bit special, we're gonna consider the parent folder as home. So it will have an ID of home, which will be the only unique one, which you'll see in a bit as we implement it. So first, we'll try and get all the folders based off of the parent ID home. We'll do the exact same thing for the files. So we'll call get files by parent ID, passing it the parent folder ID of home. And then we'll create, based off of those results, we'll create a subcontent object, and then we'll render that. This will give us access to that subcontent object in our page props further down. Next is our post handler. This will take care of saving a folder. If you remember, the modal that we created in our layouts makes a post call whenever the form is submitted. This will be handled here inside of our index route in this post handler. So in our handler, we'll first get the form data. It should have a folder field, which would be the folder name to create. If its length is equal to 0, so if we're passing it in empty string, we'll return a error response, invalid content with a status code of 400. Then we create our folder object. For the ID, we'll use the built-in crypto library to generate a random UUID. The name will be the folder name that we got from the form, and the parent folder will be hard-coded to home since we're in the index route, which is the home folder. So everything created here would be part of the home folder. Then we can call the save folder function from our database functions that we created. And last thing, we'll redirect the user to a new page that we haven't created yet, but this would represent the page of the new folder that we created. So every folder could be accessed by heading to folder / the folder ID. So let's try it out. You might need to restart the server if you added all the Deno KV unstable flag. You would need to restart it. Otherwise, it will give you an error, for example, that Deno.OpenKV is not a function. So we'll restart our server just to be safe. And now if we go to our browser, click create, let's say we want to create a folder called movies, hit submit. We should be successfully redirected to folder / and a random UUID, which would represent our movies. Now, if we head back to localhost, to the home page, we don't see our movies appearing here, which kind of makes sense since we're not really displaying the subfolders and subfiles that we're getting. We're getting them, but we're not doing anything with them here. We're just displaying some static content. So let's fix that. So let's head over to our table folder. We want to pass in some data. So specifically, we want to pass it the subfiles and the subfolders, and we already have an interface to represent that. So we can first import the subcontent interface. We then destructure in the parameters of the folders and files. And instead of displaying the static info that we're currently displaying here for the folders and the files, we want to loop over the subfolders and subfiles and display them dynamically. So I'll go ahead here and use some brackets to loop over the subfolders. So we're going to map over these subfolders, getting the specific folder, and we'll just copy this one. And now we can make use of the actual folder object to display the name. And we also want to update the link to that folder to use the ID of it. Next, I'll do the exact same thing for subfiles. So we'll map over our subfiles and we'll take in this one. And we'll do the exact same thing. So we'll change the name to file.name. And we'll update the link to it so that we'll use the file.id. Now we can remove the remaining static data that we have. And now we can head over to our index route, and we should see an error for our tables folder because we're now expecting subfolders and subfiles. So first, to get that information, we need to get it from our page props. So here we can add a props, page props, and we know that the type which we return here is of type subcontent. So now we can make use of the props, and here we can return subfolders. So we get it from the data dot subfolders, and we'll do the same thing for subfiles. We'll get it from props dot data dot subfiles. So the error should go away, and if we go to our browser, we should see our movies folder that was created successfully. Let's try and create a new one. I'll call it books. We hit submit, we're redirected to it, but if we just head back, we now see books and movies. Awesome, we're able to create folders. We also have the logic to create files. We can also fetch them, and more importantly, we're fetching them based on the parent folder ID. So in this case, the parent folder ID is home, and we're fetching all the folders and files. There's no files yet, but we're fetching all the folders that have the parent ID of home. And all that using Deno KV. So in the next video, we'll add the page to view the routes and start working on uploading the files to Supabase. Thanks a lot for watching. Bye.